So we had to discuss a square planar complex. So what is it about this square planar complex? We'll discuss. The square planar complex situation is we will take NiCN4 2 minus. Okay, this is the complex. NiCN4 2 minus. So here the nickel is having an oxidation state of 2 plus and cyanide, you know, it's Cn minus ion. Cn minus ion. So the nickel will write once again scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So these first uh, it's called first transition series. The 3D series you have to remember. So this is like D1S2, titanium D2S2, vanadium D3S2, chromium when it comes, it's not D4S2, D5S1 you will get, manganese D5S2, iron is you have D6S2, cobalt is D7S2, nickel you have D8S2, and copper when it comes, that is D10S1 you will get, and zinc D10S2. So this is the configurations. You have to remember this configurations, otherwise it's very difficult to handle this configuration method. You have to remember. Now nickel 2 plus. So when I go to nickel is D8S2 type. So when I write it for nickel 2 plus, it is like a D8 configuration. So it's like 3D8. So when I had to write for 3D8, you see this, it's like this. So 2, 3, 4. Okay. Now D8 configuration is like this. Nickel 2 plus 1, 2, 3, 4, 5, 6, 7, 8. So this is my D8 configuration. Now what it does, it has to do 4 bonds. Nickel 2 plus has to do 4 bonds. Since 4 cyanides are coming closer, it has to make 4 bonds. It has to make 4 bonds. So 4 cyanides are coming closer, it has to make 4 bonds. And now this cyanide Cn minus, it has the ability to force pair. Okay, Cn minus ability, it has the ability to force pair. To force pair the electrons. So what it does is that before its arrival itself, it will push this electron here. So you have 1, 2, 3, and 4. You have the extra 1d orbital, 1d here, 1d orbital here. In fact, 1 3d orbital here. Okay, and now 1s, that is a 4s orbital, and the 4p orbitals. Okay, 4p orbitals. Out of this 4p, you see 1d, 1, 2, 3, 4. Only 4 orbitals you need to form the complex. Okay, right? So because 4 cyanides are there, 4 orbitals, 4 vacant orbitals is what you need. And the 4 vacant orbitals dsp2, that's sufficient. So dsp2 is the hybridization is what you get, and that generates a square planar structure. Square planar structure. So how does the square planar structure looks like? So let's can have you noted, Emma? You can make a note, no problem. You can make a note.
Not yet, sir.
Okay. Now the how the square planar structure looks like. So you have nickel. The cyanides are here like this. The cyanides are here. The cyanides are here, and now it's like this. This is 2 minus. That's how you get the structure, nickel tetracyanide. So that's how you get the structure. So this is again, because the 3D orbitals are utilized, it's a inner orbital complex. And it has no unpaired electron. It has no unpaired electron. No unpaired electron. If no unpaired electron is there, that's diamagnetic. Diamagnetic. If electrons, unpaired electron is there, that's paramagnetic. Inner orbital complex, no unpaired electron, it is diamagnetic. So this you can remember. And we'll take another case of tetrahedral complex. I'll tell you about that. With that, we'll close now. Can I clear, Amma?
Sir,
Yeah, right. We have the next one, NiCl4 2 minus. This is a tetrahedral complex. I'll tell you why. You see, the Cl minus can't create a strong field. Strong field. It is a weak field ligand. We will understand that weak field and strong field later. So it will not force pair. It will not. It will not force pair. So if you understand this force pairing, that's very easy now. So nickel 2 plus once again, you have this nickel 2 plus once again. So that's a D8 configuration as I told you. So here 1, 2, 3, 4, 5, 6, 7, 8. Now these electrons, the Cl minus this electron cannot push back. So it will go to the available orbitals. So 4s and you have 4p. So 4s and 4p to combine with, you have 4 orbitals. 4 orbitals. The 4Cl minus will donate the electrons. See, each ligand donates 1 electron pair to the orbital. 1 electron pair, that is 2 electrons. 1 electron pair, or you can say 2 electrons to each orbital. This funda you have to remember. To each orbital. This funda you have to remember. This is most important. One of the important fundas which you have to understand. So here, as this electron is already there, it cannot put 2 electrons here. That's the reason it is not going here. And now these are vacant orbitals. Always this one you have to remember. Always ligands look for vacant orbitals. Look for vacant orbitals. Vacant orbitals. So this is the funda you have to remember. Always this ligand will look for the vacant orbitals. So here these vacant orbitals is 1s and 3p orbitals are available. So it is sp3 hybridization is what you are going to get. So it's the sp3 hybridization is what you are going to get. Sp3 hybridization, when I say it's sp3 hybrid, sp3 hybridization, there will be 4 orbitals, so that forms a tetrahedral complex. So how does it look like? So you can make a note. So how does this tetrahedral complex will look like? We'll see.
Okay, sir.
Okay, right, ma. Now, well, let's draw this tetrahedral complex. This is Ni. You have Cl. It's like this, very simply. Cl, Cl, Cl. That's how your tetrahedral complex look like. And then you have 2 minus on bit. So this is the sp3 hybridization tetrahedral. Like what you see the CH4 structure, right? It's like this only. It's like our CH4 structure, methane structure. Methane is a tetrahedron. So how do you see the tetrahedron? When you join like this, you have the tetrahedron. That's the tetrahedron for you. Clear? So that's a tetrahedral structure. So this will close a month. This is enough, and then I will start. Uh, if possible, I'll intimate you at by 3:30 or 4. Okay.
Okay.
So
Okay, sir.
around 16:30 hours, we'll meet again to finish off this concept. Okay, ma.
Okay, sir.
Okay, ma. Right. Take care. Have a nice day.
Thank you, sir.
Right, ma. Right. Bye.